All right, so notice just like yesterday, you have another assignment you have to go into Google Classroom for. It's another quizzes with some drill and practice that I think will help you. Those people that did yesterday's already said they found it just fine. They could do it 3 times. It worked great. You know, so I don't think there's any issues with that. But I definitely think having some more practice with some instant feedback would be good. All right, so today, before we get to what we are doing, we are going to review yesterday just a little bit. So remember, when we are doing the inverses, you only have a set number of, Jeanette, that needs to already be turned in. You need to be paying attention. You only have a set number of things that you can have as your answers, right? You have a limited array of information. So for sine and tangent, you can only give angles that are in the first or fourth quadrant. Oh, I have to draw 4. First or fourth quadrant. And we know on the unit circle, we can start here at 0, go all the way around to 2 pi, right? So this would be pi halves, pi, 3 pi halves, and that's all good and legit. But when we are giving the inverse answers, we can't talk about this as 3 pi halves. We have to go negative pi halves, 2 pi halves. Okay? Those are the only answers you can give, from negative pi halves to pi halves for sine and tangent. Make sense? But cosine is positive in the fourth quadrant, so we can't do that. So for cosine, you go from 0 to pi, which is in the first and second quadrant. So if your values, your sine, cosine, or tangent values are positive for all 3 of them, your answer is a first quadrant angle. Okay? Does that make sense? If your sine, cosine, or tangent value is negative, then the angle is either in the fourth quadrant for sine and tangent or in the second quadrant for cosine. Okay? And that's kind of the gist of all of that. So when we look at these, right? Sine inverse of 1/2, that is a positive value. It is a first quadrant angle. What is the sine inverse of 1/2? You can still use the hand trick. Here's how sine is 1/2. When the value is 1/2, the angle is pi 6. Okay. This is your pi 6 angle, cosine square root of 3 over 2, and 1/2. That's how you know your values. All right, tangent inverse of square root of 3 over 3. So if the tangent value is the square root of 3 over 3, what is the angle? Pi 6. There's 2 3's, so it's a 6. This is positive, so it's a first quadrant angle. It is pi 6. What do you mean? Right, so the tangent of pi 6 has 2 3's in it, square root of 3 over 3. So the tangent inverse of the square root of 3 over 3 has to be pi 6. It's just, it's like a number family. You know, like 2 times 3 is 6, and 6 divided by 3 is 2. It's the same relationship there. Does that make sense? All right, so then cosine inverse of 1/2. Positive value, so it's a first quadrant angle. What is that? Pi thirds, okay? All right. Then we have the sine inverse of negative square root of 3 over 2. So the first thing you can do is just kind of ignore the negative. Think about what the reference angle would be. If sine is square root of 3 over 2, that's a what kind of angle? Pi thirds, right? But this is negative, which means it's in the fourth quadrant, but I can only go from negative pi halves to pi halves, so what's my answer? Negative pi thirds. Tangent inverse of negative square root of 3. What do you think that is? Okay, so it's tangent, and this is negative, so that's a fourth quadrant answer. And then tangent inverse of the square root of 3, negative pi thirds. Okay? Because the tangent of negative pi thirds is negative square root of 3. All right, then the cosine inverse of negative square root of 3 over 2. So it's a pi 6 angle, right? So your answer would have to be 5 pi 6. For sine and tangent, every single answer you have will be a reference angle or the negative version of the reference angle, right? So if you know it's a pi thirds angle, it's negative pi thirds, because that's how you get down to the fourth quadrant. Cosine is the only one that you have to actually think about and use the second quadrant angle. Okay? We good with that? And only when it's negative. Yeah, it's just the first quadrant for all of them. Even though sine and even though all of these are positive also in another quadrant, remember that we're restricted to our domain so that we don't take all that into account. Because there's actually an infinite amount of them. Sine and tangent. And then cosine's the top. Okay, we good? All right. So let's look at this. This is going on page 107 when we are done. Oops. So it says recall, meaning that we already know this, bless you. Given the function f and its inverse f inverse, then if x is in the domain of both functions, this is what's important. It has to be in the domain of both functions for this to work just right out as it looks. So if I take the inverse of f of x, then that gives me x. And if I take f of its inverse, it should give me x. As long as I don't have any domain restrictions, it's straight up easy. But we do have a lot of restrictions here, okay? So here are the properties of these. In order for this just to cancel each other out, so the sine of the sine inverse of x equals x, then that means the x value, when I'm taking the inverse, I can only take the inverse of a ratio, it has to be between -1 and 1. Same thing for cosine. Tangent, it can be between -infinity and infinity. Right? All right, so then when I'm going in the opposite direction, if I want the sine inverse of the sine of x to just equal x, then x has to be in that -pi halves, 2pi halves. And for cosine, it would have to be between 0 and pi. And for tangent, between -pi halves and pi halves, but I'm not including them. Okay, so one of the examples that I showed you yesterday, when I was trying to help you understand it wasn't just a straight back and forth type of thing, wrote sort of this down. So we're going to write this back down at the top. Sine inverse of the sine of 7 pi sixths is not 7 pi sixths. And here is why. If this was going to be true, then x has to be between -pi halves and pi halves, and it is not. Okay? Does that make sense to you? If I said the sine inverse of the sine of pi thirds, that does equal pi thirds, because pi thirds fits between this. Okay, so these these domains here, that's the key to everything. Okay, so it's not just a straight answer like that. Even though the sine of 7 pi 6 would give you, the same value. I'm going to get all that, but it doesn't work that way. Okay? Yeah, exactly. All right, so we're going to find the exact values of each expression if it exists, right? Because some of them don't exist. So I'm taking the sine of the sine inverse of -1/3. All right, so I'm taking the sine inverse of a ratio. Is that a ratio that you were familiar with? No. Okay, so it's not one where you just know the angle, right? That's fine. Nobody's asking me for the angle anyway. I want the sine of whatever that angle is. And the answer will be -1/3 if -1/3 falls in the little range. Does it? Yes. This number, if I'm going to take the inverse, has to fall between -1 and 1. We know that, right? As long as it does, I don't know what the sine inverse is, but the sine of that sine inverse will just straight up give me -1/3. That's my answer. Okay. Now, the arc cosine of the cosine of pi force. Now, I do know what the cosine of pi force is, but it doesn't even matter what it is. If I want to take the arc cosine of the cosine of an angle, then that angle has to fall between if it falls between 0 and pi, which that does, right? Then my answer is just pi fourths. I don't even need to know what the value is, as long as it falls between where it's supposed to. Okay? So then look at arctangent of tangent of -pi halves. Is that going to just equal -pi halves? No, because if it was, then this has to fall between these two, and I don't get to include it because it's undefined, right? So since it doesn't fall within there, I can't answer this. It does not exist. Okay. Number 4, there's a little bit of a typo here. There's 2 inverses. Ignore that one right there. Okay, so I want to take the tangent of the tangent inverse of negative 9/2. Is that going to equal negative 9/2? Yes, because I can take the tangent inverse of anything between negative infinity and infinity. And so I'm good. That's between negative infinity and infinity. So those cancel out, and I get negative 9/2. Okay? All right, so number 5. The arc sine of the sine of 3π4. Does that equal 3π4? No, it does not, because that does not fit within that certain domain. Now, there are 2 different ways to work this, okay? And I'm going to work this one both ways and kind of explain to you what you can do, and then we'll just kind of do it a little bit differently as we go through. So I can just work from the inside out. If I know the value, which you don't always, like we didn't on some of those, we could work from the inside out. So basically, what is the sine of 3π4? Square root of 2 over 2. And is it positive or negative? Positive. So then this really can become arc sine of square root of 2 over 2. And then what does that equal? π4. Okay. That's one way to do it, which works just fine. It's really probably the best way. I'll show you the other way on a different one. All right, so now let's look at number 6. I want the cosine of the cosine inverse of 2/5. Does that equal 2/5? Yes, because that 2/5 has to be between what 2 numbers? Negative 1 and 1. And it is, so I'm good. It is 2/5. All right, so now arc sine of the sine of 5π3. Is that going to equal 5π3? No, this does not equal 5π3. Whatever it is, I know it's not this. So we could just do the value like we did on this one, but I'm going to do this one differently, okay? 5π3, that angle is in which quadrant? 4th quadrant, right? So 4th quadrant. So what could I call this? What's the coterminal angle to this going negative? Negative π3. Come in. So this could be arc sine of the sine of negative π3. Does that make sense? Like I could just change the angle, or I could find the value. It doesn't really matter. So then, what's the answer to this? Negative π3. Because negative π3 fits between negative π12 and π12, so my answer is just negative π3. I actually prefer just finding the value and doing it that way. That just seems easier to me, but. Why is it negative infinity to infinity? Because we have those asymptotes. Does that make sense? I think you can. Mm-hmm. Right. Yes, exactly. And because you have, and it has to do with the fractions and stuff. We'll look at that a little bit later too, a little bit more. Yes. The reciprocals, yes. Okay, so cosine inverse of the cosine of negative 4π3. Does that equal negative 4π3? No. Okay, so it does not equal negative 4π3. We at least know that much. So we're just going to go ahead and find this value. So first of all, what is the cosine of a π3 angle? 1/2, right? So just π3 is 1/2. So this negative 4π3 gets me into what quadrant? The 2nd quadrant. And in the 2nd quadrant, is cosine positive or negative? Negative. So this is a negative 1/2, right? Which means the cosine, so when the cosine value is a negative 1/2, what is the angle? 2π. It's still a π3 angle, but for cosine, it's got to be between 0 and pi, so it is 2π3. That particular angle, yes. On this one right here, This was not the case. This was actually a second quadrant angle, right? Which still happens to be positive. So yes, these two we were using the coterminal. You could have just used the coterminal angle there, and that's what I did here. But that's not necessarily the case on every single one of them. Right, exactly, because it's in quadrant 2. All right, number 9, the tangent of the tangent inverse of pi thirds. What do you think that is? Okay, so let me ask you this. What do we take the tangent inverse of? An angle or a ratio? A ratio. Now, pi thirds does fall between negative pi halves and pi halves, but that has nothing to do with this problem. Because even though it looks like a radian angle, that is a ratio. If I'm going to take the inverse, this is not an angle. Okay? It's going to give me an angle. So do you know what the tangent inverse of pi thirds is? No, me either. You don't know what that is because that's not, it would be the like, I know what the tangent inverse of the square root of 3 is. That's pi thirds, but that's not what this is. So instead, I have to think about if I'm going to take the inverse, tangent inverse, what does this number have to fall between? Because it's not negative pi halves and pi halves. Negative infinity to infinity. So does this fit between negative infinity and infinity? Yes. So the answer in the end still is pi thirds, just maybe not for the reason you initially thought. Okay? So make sure you're paying attention to, do you have a ratio or do you have an angle? Because when we look at number 10, that 3 halves, does it represent a ratio or an angle? An angle, because you take the cosine of an angle. Okay? Do you know what the cosine of 3 halves is? No, me either. It does not matter, right? Because you can only take the sine, cosine, and tangent of an angle, and then it gives you a ratio. So when you do the inverse, you have to take the inverse of a ratio to give you an angle. Does that make sense? Okay. All right, so 3 halves represents an angle. In order for this just to cancel out and my answer to be 3 halves, that angle has to fall between what? 0 and pi. The angle falls between 0 and pi. Does 3 halves fall between 0 and pi? Y'all are going to make me cry. Okay. 3.14159 is pi. This is 1.5. Does 1.5 fit between 0 and 3.1415? Yes, it does. Okay. This has nothing to do with the negative 1 and 1 because this is an angle. So this does fall between that, and my answer is 3 halves. So pay attention to whether you have a ratio or an angle. Tangent. I'm taking the tangent of an angle. That looks familiar to me, so I'm good, right? So the arctangent of the tangent of pi, does that equal pi? No, it does not equal pi. So I can say I want the arctangent of, what's the tangent of pi? 0. The tangent of pi is 0. So I'm taking the arctangent of 0, which means this is a ratio. When the tangent value is 0, what is the angle? 0. That does not fall between negative pi halves and pi halves. All right, so then I have the sine inverse of the sine of negative 11 pi 6. So that is the sine of an angle, right? I know then that this does not equal negative 11 pi 6. So the sine of a pi 6 angle is what? 1/2. It's 1/2. Okay? But then a negative 11 pi 6 puts me in what quadrant? The first. So I want the sine inverse of a positive 1/2, which gives me what? Pi 6. Which again happens to be the coterminal angle for this one, but that's not necessarily always the case. Okay? We okay with that? So make sure you're thinking of, like, these should come pretty quickly once you get the hang of it, but also just make sure you're not falling in those traps and that you're actually thinking about what the values mean that you have. Okay, so when we mix them, when it's not just the sine inverse of sine, when we mix them, then you have to work from the inside out like we already did on some of them. It actually makes it a little easier. You don't have to reason through it quite so much. So cosine inverse of the sine of pi 6. So what is the sine of pi 6? 1/2, right? So cosine inverse of 1/2 is what? Pi thirds. When the cosine value is 1/2, the angle is pi thirds. All right, so then I want the arctangent of the cosine of 0. So I'm going to write down arctangent of, what's the cosine of 0? 1. So the arctangent of, when the tangent value is 1, what is the angle? Pi fourths. And I'll say this again. If you don't know your trig values going forward with confidence, you can't go backwards. So good luck. All right, the sine inverse of the tangent of negative pi fourths. So what is the tangent of negative pi fourths? Negative 1, right? So then I want the sine inverse of negative 1. So when the sine value is negative 1, the angle is negative pi halves. So yes, but I have to call it this because of that domain I have to be in. Okay? Then the arcsine of the cosine of 5 pi 6. So what is the cosine of 5 pi 6? Square root of 3 over 2, positive or negative? Negative. Oh, I put equal. So negative square root of 3 over 2. So when the sine value is negative square root of 3 over 2, the angle value is negative pi thirds. Good. Okay. We okay with that? I know, all this thinking. All right, y'all do 17 and 18 and then stop. Oh, and on 18, it shouldn't say arctangent inverse. That makes no sense. So mark out the little inverse thing. Whenever it's arc anything, you say, if that tangent or whatever it is value is this number, then what is the angle? Okay, yeah. Okay, so on 17, that means I'm going to be looking for the cosine inverse of 1. Do we agree with that? And what is the cosine inverse of 1? 0. Good. So then on 18, I'm looking for the arctangent of negative 1. And what is that? Negative pi fourths. Good. All right, so let's look at 19. It's the same thing, but now the inverse is on the inside. So I want the cosine of the sine inverse of 1/2. So I want when the sine value is 1/2, what is the angle? Pi 6. So I just want the cosine of pi 6, which is square root of 3 over 2. Okay, so then the arctangent of 1. When the tangent value is 1, what is the angle? Pi fourths. So I want the sine of pi fourths, which is square root of 2 over 2. Good. All right. Now you do 21 and 22. Yes. Okay, so what I heard from the people back there on number 21, and I think what you were talking about was the arc cosine of 0, right? And that happens twice, right? It happens at pi halves and 3 pi halves, but you can only use between 0 and pi, and that's why we use pi halves. So very good reasoning. And then what is the sine of pi halves? 1. All right, and then the tangent inverse of the square root of 3 is pi thirds, so then the cosine of pi thirds is 1/2. Okay, we good? This gets better with practice. That's why I gave you those quizzes, so you had a little bit of drill and practice to kind of go through and process through it again, okay? So there's another one that has these kinds of things on it too for you to be able to think through. All right, so let's look at this down here. So now we're doing the same kind of thing, but this isn't a value you know. Like, you don't just know what the cosine inverse of 8 over 17 is, and that's okay. I don't either. Nobody does. It doesn't matter. So basically, when I take the inverse, this thing gives me some angle, right? So I want the tangent of whatever angle this creates. I don't even care what the angle measure is. I just need the tangent of that. So we're going to draw a picture. This is cosine, and it's positive, and they're all positive in the first quadrant. And so we had drawn some other ones where it might have been positive, but we were in a different quadrant. But that's when we could use the whole circle. We're only getting to use these 3 quadrants right now, and this is the one we use for the positive stuff, right? Theta goes here. I really have a hard time understanding why people get so confused as to where the angle is, because the whole idea is it's created by the radius that's rotating around. So then if I have cosine, which is 8 over 17, right? This is adjacent over hypotenuse. This is 8. This is 17. So I need to find the y value. Pythagorean theorem. Make that happen. Find the y value. Everybody should know. If you're taking any time wasting on that, that's why you need to know your perfect squares, because Pythagorean theorem should be the least of your worries right now. You need to go work on those flashcards again. What does y equal? No. 15. Okay. It's 15. Plus this is a Pythagorean triple, 8, 15, 17. So whatever theta is, I can now find the sine code. I can find all 6 trig ratios of the angle, actually. And so what I want then is just the tangent of the theta. And what does that give me? 15 over 8. That's it. Okay. All right, so then I want the sine of the arctangent of negative 12/5. So that means this creates some sort of angle and something I can go and draw in. This is tangent and it's negative. What quadrant am I in? 4. Okay. All right, so here's my theta. Tangent is opposite over adjacent, so this is 12, this is 5, and this has to be the negative. Then you need to go and find the radius. It is 13. This is also a Pythagorean triple, 5, 12, 13. Okay? But if you know your squares, then you should be able to get through Pythagorean theorem pretty quickly, even if you don't know your Pythagorean triples. But 25. If you want to be good at getting through quick computations on all the non-calculator stuff, you should know your perfect squares to 25. Okay. So I want the sine of theta, and that gives me what? And it's negative 12 over 13. There you go. Okay. What questions do you have? Don't forget about the quizzes. They should be fairly simple, and they are a grade.